How many people are participating in that particular relation is called as degree of relation. At particular time, how that entity is connecting, attributes are connecting to the entities, that is called as relationship instant. What is the relationship type? Relationship type represents the association between the entity type. Hello everyone, welcome to one more session of database management system. Myself Indu J, faculty in the computer science department, Vidhyaashram First Grade College, Temple of Excellence, Mysuru. Today we are going to discuss about the relationship models in the ER modeling. In the last session, we have discussed about what is ER model, what all attributes we have, what all the different things we have in the ER model. Today in this session, we are going to discuss the relationship, how we are going to provide the relationship between one entity to the other entity. Okay, here what we have is relationship type. What is a relationship type? Relationship type represents the association between the entity type. So, between two entity types, it is providing the association. How one entity is connected to the other entity is given by the relationship type. Here, example, student is an entity in the student database, course is an entity in the student database. Until unless student is registered to the course, we cannot consider the individual as a student. Only the connection what we have, enrolled. Student has enrolled to the course. This is the relationship between two entities. Entity types. The relationship is when the attributes of one entity refers to the attributes of another entity type. So that is what the relationship type is. Represents a reference as in a relationship, not the attribute. We are represent reference from which table we are referring, the attribute will be considered as a reference. Relationship type or among n entity type, relationship will be represented as R. Among n entity types, in a single database we have different entity types, that is called as E1, E2 and E3 are our entities. Relationship R on different entities E1, E2, E3 up to N defines a set of association among the entities from this entity table. How the E1 is related to E2, how E2 is related to E3 or so on, how En minus 1 is related to En. That is given with the relationship R. Okay. Next what we have is relationship instance. What is a relationship instant? At particular time, how that entity is connecting, attributes are connecting to the entities, that is called as relationship instant. That is, relationship is for R, I is for instant. Relationship instance for each relationship association and a individual entity with E1, E2 up to En. Each entity Ej in relation R is a member of entity set Ej. You should not refer any attribute which is not the part of that entity as a relationship. Okay. We have to refer only those entity which is a part of that table to provide the relation to the other table. The name of the relationship is written inside the diamond box. The name of the relation is written inside the diamond box, that is enrolled into, right? This is a name of the relationship. All entities are represented in the rectangle participating in the relationship or connected by a line. How we are giving connection? By a single line we are giving a connection. Okay. Next what we have is relationship set. Set is nothing but the values that is providing the relationship, that is called as set. A set of relationship of the similar type is called as a relationship set. Like entities, a relationship too can have a attribute. Entity will have an attribute like entity name, entity address, so on. Like that, relationship also has a attribute. Okay. These attributes are called as descriptive attribute. When relationship has some attribute, Those attributes are called descriptive attribute. Descriptive, describing the relationship, is called as descriptive attribute. The following relationship set depicts S1 is enrolled in course 2, S2 is enrolled in course C1 and S3 is enrolled in course C2. Here we have S1, S2, S3, right? Here we have course 1, course 2, course 3. This is what? This is enrolled. This is a relationship enrolled. Okay, S1 is a even enrollment to the course C2. S2 is enrolled to E2 relationship to the course C1. Here we have a direct enrollment for S3, E3 and then the course 3. Next, we are going to discuss roles. Roles are structural constraint. How we are providing the relationship, what is the role of that particular relation and on which constraint. Constraints is nothing but rules. On what all the rules we have to provide the relationship between each entities. Okay, role. Each entity type that participate in the relationship type plays a particular role in the relationship. The role is a role name signifies the role that is participating. For example, what we have taken, enroll. Okay, student enrolled into the course. That is the name of the role. Okay, what is role it is playing? Enrolling. Enrolling is a role what that relationship is playing. Okay, for example, in the work for relationship, the type employee plays the role of employee or worker, and the department plays a role of department or the employer. Okay, what is the role of the employee here? Role of the employee as a worker, and the role of the department is what? Employer. If there is a department, the employee will be recruited for that department, right? So, providing the employment is called as employer. What is the role of the department? Here, the role of the department is employer. Degree of a relationship type. What is the degree of the relationship type? How these relations are connected, in what degree they are connected, whether all are participating in the relationship or some of them are participating in the relationship. That is called as degree of relationship type. The number of different entity sets participating in the relationship set is called as degree of relation. How many people are participating in that particular relation is called as degree of relation. The degree of relationship type is a number of participating entities type. Relation type of the degree 2 is called as binary. If two relations are participating or two entities are participating in the relation, that is called as binary relation. The relationship type degree has more than 2 is called as ternary relationship. You have 3 entity type. This is entity type, entity type, entity type. 2 tables are participating, that is binary. If more than 2 are participating, that is ternary. So, depending on that, we have different types of relationship degree, that is unary. Unary means a single table, the entities, that attributes of each table are participating in the relationship. That is called as unary. Binary we have already explained. Ternary we have already explained. More number of tables or more number of entities participating is called as n-array relationship. Okay. Next what we have is example for unary relationship. Unary relationship, when there is only one entity set participating in the relationship. That is, entity is what? Person. Person is an entity type participating relation with the passport application. So, single entity having the relation is called as unary relation. Then comes to the binary relation, when there are two entities participating in the relation, student and then the course. Two entities of the student database participating in the relationship called enrolled. So, that is called as binary relationship. Next, ternary relationship, more than one. We have technician, we have notebook, we have project. So, technician is working for project. How is working? By using the notebook, or we can say manual. technician uses a manual to work on the project. So that is called as ternary relationship. So three tables or the three entities are participating for using the notebook or using the manual. So this is ternary relationship. Then what we have is n-array relationship. When there are n entities, more entities that participating in the relationship, the relation is called as n-array relationship. Okay, next, structural constraint. What are the structural constraint we have when we are providing the relationship between the entities? The cardinality ratio and the participation relationship together considered as a structural constraint. What is a cardinality ratio? How many people participating at that particular instant is in a cardinality ratio. And participation relationship, in what type of relationship they are participating, whether it is a unary, binary, ternary or n-array. This is together, put in together, gives us a structural constraint. Okay, constraint on the binary relationship type. Relationship type generally have the certain constraint that limit the possible combination of the entities that are participating in the corresponding relation. Constraint means set of rules. Without set of rules, we cannot run anything, right? We should follow some set of rule when we are designing the database. So those set of rules are called as constraint. The relationship where two entities are participating is called binary. The main type of binary relations constraint are cardinality ratio and then the participation. Depending on the cardinality ratio, we can categorize the relationship into 1 to 1, 1 to many to many and many to 1. Depending on what? Cardinality ratio, how many are participating at that particular instant. Okay, so 1 to 1, 1 to means one person is participating relationship with the other entity, that is 1 to 1. Let's see one by one what is 1 to 1 participation. 1 to 1, when a single instant of an entity is associated with the single instant of another entity. This is entity 1, only one attribute of that entity is having the relationship with the other attributes of other one attribute of entity, that is 1 to 1 relationship. Then it is called as 1 to 1. Here each entity of the entity set participating only once in the relationship, only once the entity is participating. Okay, then what we have is next type of constraint is, this is an example for 1 to 1. A is the entity type, B is the entity. A is participating with the B1, A2 is participating with the B2, A3 is participating with the B3. That is only one is participating or communicating with the one in the another table. A3, A4 is not participating with any of the attribute. Next what we have is second type of constraint. This is one more real life example for 1 to 1. Like we have a surgery department. Surgeon is heading one department as an HOD. So for one department there should be one HOD only. Next what we have is 1 to many constraint. 1 to many constraint, when a single instant of the entity is associated with more than one instant of another entity, that is called as 1 to many. That is called as 1 to many. Here the entities in one entity set can take participate in any number of times with the relationship. Let's see with a generalized example. Here one entity is participating with any number of entities, like it is marked as 1:n. The following image reflects only one instant of the entity 1 with having more than one instant in entity 2. So example for this, how here A1, one attribute of the entity table A is participating for B2 as well as for the B1. 1 is to many. Getting? Then A2 is also participating with B2 as well as with the B3. 1 is to many. But here we are going with 1 is to 1. Is 1 is to n, 1 is to n. Okay. The example here, surgery department has n number of doctor. How many? Department is only one. In one department we cannot have only one doctor. one HOD will be there, but one doctor cannot be there. So, we'll be having more than one doctors. So, n number of doctors are there. So, that is 1 to n relationship. Many to 1. We have done with 1 to many. Now, opposite of that, many to 1. So, many relationship or many entities are participating with the one entity of another set. So, here one entity set can participate only once in the relational set, and the entities in the another set can participate more than once in the relational set. So, that is represented as n is to 1, that is many to 1. Let's see the diagrammic representation. Here entity 1, entity 2 relationship. Here many number of participate with the many number of participant is communicating with the one number of participant in the entity 2. Here you can see in A and B entity, here A is participating with the B1, A2 is participating with the B1 and A3 is also participating with the B1. Only n entity communicating with the different entities in the first entity table, that is n is to 1. Okay. The same thing, real life example what we have is multiple surgeries can be done by a single doctor. Right, multiple surgeries can be done by single doctor. A surgery department can have multiple doctor, that is surgery department. One department can have multiple doctor, but multiple surgeries can be done by one doctor. So, this is many to one. Then many to many. Both in the both side, there is no restriction, there is no constraint on the participation. Any number of the participants can participate with the any number of the attributes, that is many to many. Here you can see A1 is participating with the B1, B2 as well as with the B3. A2 is also participating with the B1 and then B3. A3 is participating with B1, B2 and B3. All the instant, that is many to many. The same thing, real life example, employees works on multiple project. We have many number of employees who are working on many number of projects. Okay, that is what about the constraint based on the cardinality ratio. Now, participation constraint, how the participation can be done. There are two types of participation constraint. One is total participation and one is partial participation. What is total participation? Each entity is involved in the relationship, that is total participation. Full, all the entities of this entity 1 table are putting their effort or having the relationship with the another entity, that is total participation, and it will be represented with the double line. Okay. Then partial participation, not all the entities are involved in the relationship. Partial participation is represented by the single line. This is total participation and this is partial participation. Okay. So, all the student has to enroll into some or the other courses. It doesn't mean that all the courses should have the same student. Getting the point? All the student, unless he has to enroll into some course, he cannot be a student. So, all the total student has to enroll to some courses, that is total participation represented in the double line, but all the courses cannot have same set of student, right? So, that is partial participation. How these are dependent? See, every student in the student entity is a participating in the relationship, that is enrollment relationship. Student 1, student 2, student 3 and student 4. But here you can see C2. C2, that is a course. Course 2 is not having any relationship with the any student. All the student either opted course 1 or they have opted course 2. This is a partial participation and this is a total participation. Okay, hope all of you got the clear idea about entity relationship model. Thank you.